Hi, in this video, we are going to look at more examples for DFA construction. So we have seen many examples for constructing finite and non-finite DFAs, and we will continue our journey. In this example, we are going to construct a DFA which accepts binary strings that end in 0, 0 or in 1, 1. So since it is given that it is binary strings, we already know that the set of alphabets is defined as 0, 1, because it's a binary string which can contain only 0 and 1. And now we have to look at the string patterns which has to be accepted. So in this case, we have to accept the minimum strings which we need to accept are 0, 0, because 0, 0 ends in 0, 0. And we have to also accept 1, 1, because 1, 1 ends in 1, 1. So we also have to accept strings like 0, 0, because 0, 0, 0, 3 zeros. This also ends in 0, 0. Yeah, we also have to accept 1, 1, 1. So this also accepts, this is also ending in 1, 1. So this is how we are going to define, we are going to construct a DFA. We have to look at the very simple strings which has to be accepted, and then we will slowly build it. We also know that our DFA should accept strings like, say, 0, 0, 0, 1, 1, because it also ends in 1, 1. Similarly, it has to accept strings like 1, 1, 1, 0, 0. This also ends in 0, 0. So let's start constructing the DFA. So let's say I am having a starting state, say Q0, and I'm going to make this string gets accepted first. That is 0, 0 gets accepted first. So I'll be giving a transition from here as 0 going to Q1, and from there I'm having another transition that is Q3, and that is a final state. And here I am going to have 0. So the string 0, 0x is going to be accepted by this. Now what we will do, if you are getting continuous pattern of 0, 0s like 0, 0, 0, this also should be accepted. If you are getting 0, 0, 0, 0, 0, so all these continuous patterns of zeros should be accepted. So from here, if you are getting a 0, if you're getting keep on getting zeros, then you can stay here itself, because as you're getting continuous patterns of zeros, you can stay here itself. So so that we will accept all the strings which is having a continuous pattern of zeros. So what we will do if you are getting a 1, 1, so this also should be done. So so from here, from the initial state, if you're getting a 1, so I'm going to have another state, say Q4 here, and if you're getting a 1, I'm going to go there. So if you're getting a 1 from Q0, I'm going to go to Q4, and from there again, if I'm getting a 1, I have to be in my final state, because 1, 1 is a string which ends in 1, 1. So it has to be accepted. So I'm going to have, if I'm getting a 1 transition from there, I'm going to draw another state which is called Q5, and Q5 is a final state. Okay. So so we have also done with 1, 1. So what we will do if we are having continuous patterns of 1, 1, like 1, 1, 1 or 1, 1, 1, 1. So all these must be accepted. So we are going to have a transition showing, if you're getting a 1 from here, you're going to stay at Q5 itself. So that part is also taken care of. So now our DFA will accept all patterns of 0, 0s. And it also accepts 0, 0 and 1, 1, and all other patterns of continuous patterns of zeros and continuous patterns of 1. That is guaranteed. Now look at this case. From Q0, if you're getting a 0, you're at Q1. From there, if you're getting a 1, what you will do? So if you're getting a 1 from here, so let me take my pointer to make it more clear. From this Q1, if you're getting a 1, which means you have got a 1. So again, if you are getting a 1, you are having the chances that it is if your string is ending there, and then you are having the chances that you are going to accept that string. So from Q1, if you are getting a 1, so what you can do is you can actually go to Q4, and from there, if you are again getting a 1, then there are chances that your string ends in 1. So that's the thing that make us to decide from Q1. If you're getting a 1, you're going to go to Q4. Similarly, from Q4, if you're getting a 0, what we will do is that we'll go to Q1. So if you're getting a 0 from Q4, we'll go to Q1, hoping that if you're getting a one more 0, we'll be in one of the final states. Okay, so that we'll be in Q3, and that's a final state. Okay, so that transition is also defined. Okay, from here, and there are a few more things to be defined. So from Q3, if you're getting a 1, which means if you're getting something like this 0, 0, 0, 1, that again should go to Q4. So if you're getting a 1 from Q3, you have to actually go to Q4, hoping that you'll get one more 1, and then you will be in Q5. Similarly, from here, from Q5, if you're getting a 0, you can actually go to Q1. So this is the transition. If you're getting a 0 from here. So if you're getting a 0, you go to Q1, hoping that you'll get one more 0 and you'll be in the final state. So so I think our DFA is complete. Before, how to verify that? How to verify whether your DFA is complete? You can actually put in some strings and verify. Before that, you have to check that all transitions at all the states are defined. For example, in the case of Q0, you can see that 0 transition is defined here. And one transition, the transition upon 1 is defined here. So this should be valid for every state. For every state, there must be transitions of 0s and 1s, because our alphabet set contains 0s and 1s. So suppose that if our alphabet set contains, say, 0, 1, and 2, then we should make sure that all transitions for 0, 1, and 2 are present in each and every state. So for in this DFA, we have only 0 and 1. So we should look at all the transitions from all the states. We should check that transitions for 0 and 1 are available. So from Q0, we have verified that we have the 0 transition and the 1 transition. From Q1, we have the 0 transition here and the 1 transition, which goes to Q4. That's also fine. Again, from Q3, you have the 0 transition here. You have the 1 transition here. So that's also good. From Q4, you have the 0 transition going out, and you also have the 1 transition going to Q5. And from Q5, you have the transition for 1 as well as the transition for 0. So this DFA contains all the transitions. And we will also have to check with few complicated examples. Like suppose if we want to check whether our DFA is working in all the cases. Let's check with 0, 1, 0, 1, 0, 1. This string is not ending with 0, 0 or 1, 1. So this should not be accepted. Let's check what will happen, how our DFA will deal with this. So upon getting this 0 here, the first 0, the transition happens from Q0 to Q1. And upon getting again 1 from here, we are at Q1 now. And if you're getting a 1 from here, we are going to Q4. So now we are at Q4. A 0. We are again getting a 0. Now from here, we are again getting a 0. So what we will do is we'll go back to Q1. That means now we are at Q4. We are at Q4, and then upon getting a 0, we'll go back to Q1. You can see that from here again you have a 1, so we'll come back to Q4, and again you have a 0, so we go back to 0. And again, you have a 1, so you come back to Q4. So as long as the string pattern is 0, 1, 0, 1, 0, 1, our DFA will function like, there will be a looping from Q4 to Q1. This continuous looping will happen, and we will never reach the final state. So as long as the string pattern is 0, 1, 0, 1, 0, 1, we will not be reaching the final state. So let's look at another example. So let's say our string is 0, 1, 0, 0, 0, 1, 1. What will happen? Let's look at this. So what will happen? So we are having the 0 first, and upon getting the 0, we'll make the transition. We'll have the transition from say Q0 to Q1, and the next one is a 1. From there, if you're getting a 1, you go to Q4, and from there you have 0, so you'll go to Q1. From there you have again another 0, so you'll go back to Q3, hoping that this is the end of the string, but unfortunately it is not. Again you are getting a 0, so you stay there, hoping that it is the end of the string, but it is not the end of the string. You have 1, again 1, 1. So upon getting a 1, you go here, and you also have a 1 again. So you can see that it reaches to the final state. So this string 0 1 0 0 0 1 1 is getting accepted because it ends with 1 1. So you can actually check for any other strings which ends with 0 0 and 1 1. You have to verify that all such strings are accepted by our DFA. You should also verify that the strings which are not ending in 0 0 or 1 1 is also not getting accepted. So two things are important. You have to make sure that all the strings ending with 0 0 and 1 1 are getting accepted, and all other strings which are not ending in 0 0 or 1 1 should not be accepted. It is asked to construct a DFA for accepting binary strings that contains 0 1 as a substring. So the notion of a substring is like this. So when you want to have 0 1 as a substring, you can have anything and then a 0 1 and then anything else. You can also have 0 1 is also a valid string for this language, because 0 1 itself is a string that contains 0 1 as a substring. And you can also have 0 1 followed by something else, or you can also have something followed by 0 1. So all these 4 varieties, all these are varieties of strings having 0 1 as a substring. So the minimum string in which it contains 0 1 as a substring is 0 1 itself. Okay, so we can also have, we'll look at some very basic examples of this language. 0 1 is acceptable. 0 0 1 is also acceptable. 0 0 1 1 is acceptable because you have 0 1 here. Also, you can say 0 1 0 is also accepted because you have 0 1 here in the beginning. So here you have 0 1 in the end. Here in this example you have 0 1 in the beginning, and in this example you have 0 1 in the middle. So you have got 0 1 in the middle. So all these type of strings, all these different types of strings has to be accepted. So let's start building the DFA. So the idea is that we have to start making with the simplest strings and then move to the complicated ones. So let's start doing it. So let's say our starting state is Q0. So you should remember that always you have the starting arrow to be represented in the starting state, and we have to accept 0 1. So let's it's very easy. You have to have a 0. Upon 0 transition, you are going to Q1, and then upon 1 transition, you are going to Q2, and this should be a final state because 0 1 has to be accepted. Now we can also say that 0 1 followed by anything as represented here has also to be accepted. So if you are getting a 0 1 in the beginning, it should be accepted. So you are not bothered about what you are getting after that. So it means that if you are getting anything, so it can be a 0 or a 1. If you are getting anything, upon getting anything from here, you are going to accept it. So this will cover 0 1 and 0 1 followed by anything. So now what we will do if I'm getting a 1 here. So initially, suppose the string is like this, say 1 0 1 0. So as long as you are getting a 1, you are going to stay here. So as long as you are getting a 1, you are going to stay here. And when you are getting a 0, you are going to make a move from here to here, expecting to get you are expecting to get a 1, and then you are going to the final state. So as long as you get a 1, you stay there in Q0. Now 0 1 can occur in the middle also. So to handle all such cases, we should make a small transition here. That is from Q1, from from Q1 you have to make a transition upon getting 0 to Q1 itself. So because if you are at Q1 and then you're getting a 0, and if the next alphabet that you're getting is 1, then you're going to end up with the final state. So suppose so this will handle all the cases with 0, 1 as a substring. It will also handle all the cases. Our DFA will handle all the cases with 0, 1 as the string that occurs in the last. So let's verify this Q0 from, if you are looking at Q0, let me take my pointer. So if you're looking at Q0, you have transitions for 0 and 1. 0 and 1 transitions are defined. If you're at Q1, the 0 transition is defined. From Q1, the transition for 1 is also defined. Similarly, from Q2, you have 0 transition and 1 transition, both going to Q2 itself. So all the transitions are defined on all the states. So you can actually verify with some examples that this will work. So let's look at some examples. Like, say, I'm taking an example like 0, 0, 0, 1, 0, and 1, 1, 1, 1. So let's go through it. So once you're getting let me take my pointer and then explain. So the first alphabet here is a 0. So from Q0 you are going to shift from Q1, and you're making the transition from Q0 to Q1 upon seeing the first 0. So here you're hoping that you'll get 1 and then you'll be accepted. So but here you note that you have 2 more zeros. So when getting a 0, you'll stay here in this Q1 itself, and when you're getting another 0, again you will stay here, and then you're getting a 1, and then you're getting a 1. Okay, so once you get that 1, then you can actually see that the 0, 1 substring. 0, 1 substring is already got. You already have got 0, 1 substring. So now you're actually not worried about what is left out. So once you get a 0, 1, then it will be accepted. So this can be verified for all cases. You can easily see that 0, 1 itself is accepted. 0, 1 followed by anything is accepted. And in this example, we have seen that 0, 1 is coming in the middle. So this is also accepted. So anything, this combination is also accepted. So suppose I have 0, 0, 1, 1, then 0, 1. Let's look what will happen here. So in this case, the string ends with 0, 1. So the first transition here is 0, and from Q0, if you are at Q0, then upon getting a 0, you'll go to Q1. Again, you have a, let me take my pointer. Okay, so the first alphabet here is a 0. Upon getting that 0, I will, from Q0, I will make a transition to Q1. Upon getting the next 0, I will be staying here in Q0 itself. Then we have a 1. So upon getting that 1, I will be in Q2. So you have actually a substring 0, 1 here. Even though this, so upon getting this 0, 1 itself, this string will be accepted. So it will no more look. It will never look into the later part. So let's look at another example. This example is not a valid example for strings that end with 0, 1 and does not have any other substrings having the value 0, 1. So let's look at a slightly different example. Suppose I have 1, 1, 1, 1, 1 followed by 0, 1. Okay, this is a typical example where the string ends in 0, 1 itself. So what will happen here? So let's look at it closely. Okay, so you have you can see that there are 1, 2, 3, 4, 5 ones. So as long as you are getting ones from Q0, you are going to stay here itself. So you will loop here 5 times. So you are getting 5 ones, and then you're getting a 0 followed by a 1. So now you'll be in the final state. So we can verify that all these different varieties of strings are getting accepted for this particular DFA, and that's it. We want to make a DFA for accepting binary strings that contain 0, 1 as a substring. And actually, this question can be framed in different ways. Actually, instead of 0, 1, the question can be asked about binary strings that contains 1 0 as a substring. So here in the transitions you have to make the small change, that is instead of 1 you have to have the transition of 0, and instead of 0 you have to make the transition of 1. So this is also a very similar question. Instead of 0 1, if you're asked to construct binary strings that contains 1 0 as a substring, it is very quite similar to this. Only thing is that you are going to switch zeros and ones. And similarly, instead of asking like this, you can also be asked like binary strings that contains. It's not binary strings that contain strings containing AB as a substring, AB as a substring. Oh, sorry. Strings that contain AB as a substring, and where the alphabet set is defined as A, B. So your alphabet contains only A and B, and you are asked to design a DFA to accept strings that contains A, B as a substring. Similarly, this can be reversed also. It can be asked to find instead of A, B, you may be asked to find the strings that contain BA as a substring. So all these types of questions will definitely get a DFA very similar to this. So instead of zeros and ones, you have A's and B's here. That's all the difference. Okay. So let's look at some more examples. So this is another interesting example where we want to accept strings that contain AA or BB as substrings. So let's look at the very simple strings which has to be accepted by this DFA. So this DFA has to accept AA. This also has to accept BB. So AA, BB both contain either AA or BB as a substring. It also should accept AAA because it also contains the substring AA. It should also accept BBB. So these are the very simple strings which has to be accepted by this DFA. So remember, always you always try to come up with the very simple strings and build the DFA for that, and then further make it work on that and make it make it the real DFA that we want to. And some more examples, we can also have something like A, B, B, A. This also has to be accepted. Similarly, B, A, B has to be accepted. So all these are different types of strings that has to be accepted by our DFA. So let's start constructing this DFA. So let's look into it. So we have the initial state as Q0, and let's do for AA. So if you're getting an A, move to Q1. This is very simple. You're getting again an A. Again, if you're getting an A, move to a final state, say Q3. Q2. So now Q2 by itself has to be a final state because it has to accept AA. And suppose that if you're getting any any consecutive patterns of AA should also be accepted. So I will have a transition of A which stays at Q2 from Q2 itself. Okay, so from here, if I'm getting any patterns of A, I will be staying in Q2 itself. Now we have to also look at the case for BB. So if you want to draw the BB transition, so if from Q0, if you're getting a B, you may go to Q3. Okay, so you're getting a B here. Upon getting a B, so don't forget to put the arrows, and also don't forget to put the starting state arrow. It is very important. This starting state arrow has to be put. So from here again, if you're getting a B, from Q3, if you're again getting a B, then that means you have to go to the final state. So let's try this one. So if you're getting a B from here, I'm going to the final state. Okay. Now, okay. Now what we will do if from Q0, if you're getting an A and then you're getting a B, then the transition from the transition from Q1 upon B is not defined. Okay, So so if you're getting a B, it means that if you're getting a B from Q1, it means that there's a possibility of going to the final state. Going to the final state if you get one more B like this. So if you're getting one more B, you can actually go to the final state. Similarly, if you're let me take my pointer and explain it. Similarly, if you're at Q3, that means you have already seen B. You have already seen B, and then you're at Q3, and then if you see an A, if you see an A, then you have to make the transition to Q1, because you are hoping to get another A and then reach Q2. So that's a way how you can think about it. So if you are getting an A from here, from Q3, you can actually go to Q1. Okay, so let's now look at whether all the transitions have completed. From Q0, let me take my pointer. So from Q0, you have transitions for A and B. That's okay. From Q1, you have transition for A, you have transition for B. That's good. And from Q2, you have transition for A. Okay, you don't have transition for B here. Well, let's look at Q3. From Q3, you have transition for A and transition for B. From Q2, what you will do if you're getting a B, A or a B, what will be the transition if you're getting a B? It's very simple. You stay at Q2 itself. So I actually forgot to draw the transition for B. So you can actually put a comma here and say B, because once you've seen an AA, you don't actually bother what is the rest of it. Similarly, if you've seen a BB in this path, then you are not actually bothered about the rest of the string. Similarly, if you've seen an AA, you are actually not bothered about the rest of the strings. So now let's look at some examples and make it clarified. Let's look at these examples itself. So let's see what will happen if I am having A, B, B, A. So if once I got an A, once I am looking at the first alphabet, I am here from Q0 to Q1. Then I have two Bs. Okay, so I will be going here. Upon seeing that, I will be going here. So I am in Q3. Again, I am seeing one more B. So I am at the final state. So whatever is followed, I'm not bothered. Similarly, in this case also, B, A, B is the string. So when I get a B, when I get a B from Q0, I will go here, and from here, when I again get an A. When I'm getting a B, I'm at Q3. When I'm getting an A, I will be at Q1. Okay, and from there, if I'm again getting an A, I will be in the final state. So I'm not bothered about the rest of the string. This string will be accepted. So whatever whatever is followed by, I'm not really bothered. So this is the final state, and this is an example of saying we are actually bothered about the OR clause here. So we said that the strings which contains AA, we said that the strings which contain AA or strings which contain BB as substrings. Okay, this type of question can be asked in many different ways. Okay, so you can also be asked about binary strings that contains 0, 0 or 1, 1 as a substring. So this is another formulation of the same question. Similarly, you can be asked like 1, 1 or 0, 0. So all these questions are the same questions, are going to be representing the same DFA. Okay, the same DFA. Okay, let's look at a few more examples. Now let us look at a slightly more tricky example. So in this example, it is asked to find strings which contains even occurrences of AB. Okay, so this question can be framed in a different way. It can be like this. So it can be asked to find strings or binary strings that contains even occurrences of 0, 1. So it can be also asked in the other way. Binary strings having even occurrences of 1, 0. So all these ways question can be asked, and all these actually refer to a very similar DFS. So let's look at this example, and based on which you can actually draw these examples also. So we are going to design a DFA which contains even occurrences of AB. And remember, the alphabet set here is A, B. So there is a very important thing to be remembered here. Whenever you are asked about even occurrences, remember that 0 is also an even number. Okay, so we have to actually account for strings that contain no AB at all. You know, suppose your string is just, say, BA is your string, and it does not contain AB, but it should be accepted because there is only a zero occurrence of AB. This is very important. So if your string is just B, then also this should be accepted. If your string is just A, then also this should be accepted. Suppose your string is BAA, then also it has to be accepted, because in all these cases there is no occurrence of AB, and that's zero occurrence of AB. So in all such cases, our DFA should accept the string. So let us look at the very simple strings which has to be accepted by this DFA. So as I've told already, the epsilon string should be accepted. The epsilon string should be accepted. Let me make it very clear. So the epsilon string should be accepted because it doesn't contain it contains zero occurrence of AB. So similarly, A should be accepted, B should be accepted, BA should be accepted, and then AB contains two ABs. So when you say even occurrences, it can be 0, 2, 4, etc. So the string AB contains two occurrences of AB, so it should be accepted. What about AB? This should not be accepted, right? Because this has 3 occurrences of AB, which is not an even number. So if you have 4 ABs, this has to be accepted. Okay, similarly, you should also accept strings like, say, BAB, AB, A, because it contains 2 occurrences of AB, 2 occurrences of AB. So based on this framework, we can actually build our DFA. There are many more strings which will have even occurrences of AB. So let's begin. So the initial starting state Q0 is the starting state. Q0 should be a final state also, because epsilon has to be accepted. Epsilon does not contain any ABs. That means it contains 0 ABs. And 0 is an even number, and therefore epsilon should be accepted. That's why we are drawing the initial state itself as the final state. Now, if you're getting an A from here, then you're going to Q1. Okay, so you are actually seeing a pattern of A, B. So you started to see A. So you are actually shifting to Q1. But remember, A does not contain, if the string is just A does not contain even a single AB. So it contains 0 occurrences of AB. So Q1 also should be a final state. Q1 also should be a final state. Similarly, from the starting state, suppose if you're seeing B, the first alphabet itself is B, and then you are continued to see B. Okay, so in that case also, in this case also, you are having the string as B, or say your string that you see is B or BB or BBB. So all these strings does not contain even a single occurrence of AB. So all these strings should also be accepted. Okay. So in case that if you see a BB continuously, it has to be accepted. In case if you see an A, you have to go to Q1, but Q1 also should be a final state, because A by itself does not contain any occurrence of A. AB. Okay, now we'll move further. Suppose if I getting a B from here. Okay, so I will move to Q2. Okay, so it means that suppose if you have came from Q0 to Q2, it means that you have seen a single occurrence of AB, and and therefore Q2 should not be a final state. That is, here we have seen AB only for once, and 1 is not an even number. Now, suppose if from Q2, if you are again seeing an A, then you can actually move to Q3. Okay, and from there again, if you see a B, okay, again if you see a B, you can actually make the transition to Q0. So it means that let me take my pointer and explain. So from here, if you see an A, you are at Q1. Okay, Q1 is a final state because A, the single alphabet A should not be accepted. Similarly, from Q1, if you see a B, so you have seen an A and then followed by a B, you are at Q2. Q2 should not be a final state because it doesn't contain even occurrence of A. Now, if you're seeing an A and then followed by a B, then it should be a final state because you have seen two occurrences of A. Now, what if your string contains A, B, A, B, A, B? This contains three occurrences of A, B, and it should not be accepted. Let's check what will happen. From here, if you see an A, B, you will move here, and then again if you see an A, B, you will be here, and again if you see A, B, you will be at Q2. So it will not be accepted. If you're seeing an A, B again, this contains four occurrences. So it will be accepted. So let's look at it. So if you see AB, 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 you are here, and again an AB, you will be again back to Q0, and that will be an accepting state. So now we can verify that all the even occurrences of AB starting from 2, 4, 6, 8, all these occurrences will be accepted at Q0. So that is verified. Now let us look at some other transitions also. So from Q0, you have transition for A and transition for B are defined. From Q1, you actually have not you have defined the transition on B, but the transition on A is undefined. So let's look at it. So suppose if you're at Q1, that means you have already found an A. And again, if you see an A, then what should you do? You should be staying here itself until you see a B. You have to stay here itself. So suppose our string is A or AA or AAA. So for all these, you have to stay here because it's also a final state because you are seeing 0 occurrences of AB. So again, from here, so from Q1 now we have the transition for A and transition for B. Now from Q2, the transition of A is defined. What if I'm getting a B here? So what we'll do if we are getting a B here? So the idea here is that you are at Q2 because you've already seen an A, B. And again, if you are seeing a B, what you will do is you have to stay here in B. If you're seeing a B here, that means if you're seeing a B, B pattern, then you have to be here in Q2 itself. So what happens next if you're seeing an AB? Then okay, so you can have any number of B's here. So as long as you are seeing ABs, you are going to stay in Q2 itself. And then if you see an AB, okay, followed by all these B's, if you're seeing an AB, then you are going to move from Q2 to Q3 to Q0, and so you will be in the accepting state. So now that we can actually check whether we have done. Okay, but there is something more to be done. We have forgot to add a transition here. So suppose that you're getting an AB followed by an A. Then suppose if you're getting an A, okay, so you have to be here itself because you have only seen. So if you look at the string ABA, then you have seen only one occurrence. one occurrence of AB. So until if you keep on getting A's, that doesn't increase the number of ABs there. So you have to stay here, and then once you get a B, you can actually so as long as you are getting A's, you can stay here, and once you get a B, then that means you are getting two occurrences of AB. So you can actually make a shift from here, from Q3 to Q0 once you see a B from there. So so in this case, looking at the DFA, we can identify that all the states are having all the transitions. So Q0 is defined, the transition on A and B is defined for Q0. Transition on A and B is defined for Q1. Transition on A and B is defined for Q2. Transition on A and B is defined for Q3 also. So this DFA, you can verify that this DFA works for accepting strings that contain even occurrences of AB. And it's very important to remember that this can also be used to verify binary strings containing even occurrences of 0, 1, or similarly, binary strings that contain even occurrences of 1, 0. So what if the question is asked about odd occurrences? So the question can be slightly modified, that you have to actually accept the strings containing odd occurrences of AB, or 0, 1, or whatever. So so this is actually very easy compared to this problem. Here this is a little tricky, because you have to make sure that you are doing everything to accept strings that contain no ABs at all, because no ABs means 0 ABs, and 0 is an even number. This is very important. So odd occurrences means you have to verify that the string contains 1 occurrence, 3 occurrence, or 5 occurrence, and so on. Odd occurrences of AB means you can accept string AB. You can accept AB. You have to accept, but AB should not be accepted. AB. If you are looking at this AB, this should not be accepted. So I will be providing this as an assignment in the assignment slides, so you can actually work on that. So let's look at another example. In this example, we are asked to design a DFA to accept strings that contains exactly 2 A's, where the alphabet set is A, B. So so we have to look at the minimum strings which fall in this category. So AA is definitely has to be accepted. BAA has to be accepted because it contains 2 A's exactly. AAB has to be accepted. Again, it contains 2 A's. ABA has to be accepted because it exactly contains 2 A's. What about ABAA? This should not be accepted because it does contain 3 A's. So these are all some examples where we have to accept. So let's start building this from the very minimum, from looking at the minimum strings. Let's say we start with Q0 as our starting state, and upon getting 2 A's, this is very trivial. Upon getting 2 A's, you are in the final state. So Q2 will be your final state. So don't forget to draw your arrows and write all the transitions. So from here, now suppose you are getting an AA, then you're at a final state. Now, if you're getting an A from here, so what has to happen? So that means the question is to verify, our string has to contain only exactly 2 A's. So if it contains anything more than 2, it should, that string should not be accepted. So we will be moving to another state, say Q3, which is not a final state. So from here, if you see again an A, the string is not going to be accepted. And from Q3, you are actually not bothered about seeing an A or a B. because even you have already seen 3A's. That's why you are at Q3, and from there you are actually not bothered about what you're seeing. So in all cases, that string will be rejected. So so that part is okay. Now what if I'm getting a BAA? That should be accepted, right? So what I will do is, so from Q0, if I'm getting a B, as long as I get a B, I will stay here. So when I get an A, I will make a move to Q1. Okay. From Q1, if I'm getting a B, so suppose that I'm getting BAB. Okay. So if I'm getting BAB, we can see that our string already contains one A. Okay. So if you're getting one more A, then it can be accepted, because the restriction is that it should exactly contain two A's. So from here, from Q1, if you're seeing a B, you can stay here itself. You can stay here itself, and once you are getting an A, you will be in the final state because you have seen two A's. And from here, if you are getting an A, then you can move to Q3, which is not a final state. And from there, if you are getting an A or a B, you are not actually bothered. From Q2, if you are getting a B, suppose if you are continuously getting a B at Q2, then you can stay there at Q2 itself. Which means if you're seeing BA, and then now you've seen two A's, then so let's go through this example. So let me take my pointer. Okay, so from here, if you see, you've seen BA. So let's look at what is happening. So you have seen B, then an A, then followed by a B, and then an A. So you are at Q2 now. You are in the accepting state because you have already seen two A's. Now from here, if you again see an A, from here, if you again see an A, then you're going to a non-final state. That's okay. Okay, so let's check whether all transitions are defined here. So from Q0, you have A and B transitions. From Q1, you have A transition and B transition. From Q2, also you have A transition and B transition. From Q3, also you have A and B transitions. So our DFA is complete. You can actually verify this with putting different strings and verifying this. Okay, so there can be also questions like at most or at least two A's, strings containing at least two A's, or strings containing at most two A's, etc. So these questions are also can be worked out in a similar manner. I will be providing this as assignments. Okay, so we have actually discussed 5 different types of examples. Okay, you can actually build different other examples similar to this. I will be giving some assignments based on these 5 examples, and you are expected to submit this assignment in this week. So in the next slide, you can actually find the assignments. So we'll look at the assignments. The first assignment is all the assignments are for designing DFAs for accepting the string patterns as given. And remember that we always assume that the alphabet set is A, B. So the first question is to make sure create a DFA to accept strings that contain A as a substring, 4 A's as a substring. We have seen similar examples. The second example is to find strings that contain AAA or BBB as substrings. So it has to accept both cases. If that particular string contains AAA or BBB, it should be accepted. And similarly, the third assignment is to find out strings which contain odd occurrences of substrings of AB. So we have actually worked out we have already seen the even example. So you have to work out for the odd example. Actually, the odd example is simpler compared to the even example. And then we have to also look at you have to also solve for strings that contain at least 2 A's. The wording is very important. It is said that at least 2 A's. And this is not very complicated. This is somewhat easy. And So you can also try for at most 2 ways. This is kind of a tricky one, but you can actually solve it. So these are the assignments, and these assignments are expected to be submitted in this weekend. Okay. So if you have any doubts or queries, you can actually if after watching the videos, if you have some doubts, you can always discuss that during the live sessions. Thank you.